Welcome to qnawire.
Hello students, the free body diagram for this problem will be as follows. According to this free body diagram, we can say the normal force will be equal to mg cos theta plus f sin theta, and the frictional force will be equal to mu s Fn, which is equal to mu s into mg cos theta plus f sin theta. Since we know the summation of forces along the horizontal component will be equal to 0, for attaining the equilibrium condition, we can say F cos theta minus the frictional force minus mg sin theta will be equal to 0. F cos theta minus mu s into mg cos theta plus f sin theta minus mg sin theta will be equal to 0. So F will be equal to mg into sin theta plus mu s cos theta divided by cos theta minus mu s sin theta. From this we can say when cos theta minus mu s sin theta is equal to 0, the force tends to infinity. So cos theta minus mu s sin theta is equal to 0. Mu s sin theta is equal to cos theta, and mu s will be equal to cos theta divided by sin theta. Here theta is equal to 26.5 degrees. So mu s will be equal to cos 26.5 degrees divided by sin 26.5 degrees. So mu s will be equal to 2.005. At this particular value for mu s, even though we apply an infinite force, the object does not move. For the part B of the question, since the box is moving, mu k is applicable. The value of mu k is given as 0.33. So the equation becomes F is equal to mg into sin theta plus mu k into cos theta divided by cos theta minus mu k sin theta. Substituting the values, we get force is equal to 30.5 into 9.8 into sin 26.5 degrees plus 0.33 cos 26.5 degrees divided by cos 26.5 degrees minus 0.33 sin 26.5 degrees. So the force that need to be applied, F will be equal to 296.44 newtons. I hope you found this video useful. Thank you for watching this video.